Hi, these are three equations that were posted from day 5. Just questions about the unit in general. It was how to solve equations when you know one irrational root, how do you write equations when you know the roots, and then solving quartics when you can't factor or just in general. So I'm going to look at page 381. That's the self-test 2. And the question that I'm just going to go over is particularly question number 6 and letter B. So if you want to look at question number 6 on page 381, go ahead. So this question number 6, again, this is going to be part B. It's actually going to answer question number 1, how do you solve when you know a root, and how do you solve quartics you can't factor. Can't factor this one, and the known root that they give us is the root is, looks like 2 plus I. So what do I do kind of first? Well, if I know one irrational root, I should know a second one because the conjugates are always roots. So if I know 2 plus I, then I know 2 minus I is a root. What that also tells me is that I can write them as factors. Again, factors would be, and this is a little strange, but it would be x minus the value and x minus this value. And if you distribute, it actually turns out, and I'm just going to write the factors over here, the factors turn out to be x minus 2 minus I and x minus 2 plus I. Makes sense. Those are my roots. These are my factors. So if you know one rational root, irrational root, you know the other irrational root. They always come in conjugate pairs. And then what do you do with those two factors now is you're going to actually distribute them together. You're going to multiply and get x squared. It's going to turn out to be minus 2x. And then I think it turns out to be, let's see, if I multiply them together, I think it turns out to be plus 5. And again, we can show the work for that. I went through and I quickly checked my work. I got an x squared. I realized that I did need to check that that's actually supposed to be a negative 4x. The I-x's cancel. There's my 4 minus an I, so it's plus 1. So I get 5. And these two should cancel. This one actually turns out to be a positive. So as you go through, you get this factor. And why is that helpful? Because we've learned long division in this chapter. So how do you solve equations when you know one irrational root? You can distribute, you get a factor, and then you're going to use long division to divide out that factor. So you're going to divide this value or that polynomial into your original polynomial. And again, you get how do you make that happen? This would become a 2x squared, so that you get a 2x to the 4th. You would get a minus 8x cubed. You would get a a positive 10x squared. You subtract 9 minus an 8, this would become a negative 1x cubed plus 3x squared. Bring that one down. I would need a negative x to make this a negative x cubed. Makes that a positive 4x squared. Makes that a negative 5x. You subtract. Those become 0. This becomes what? Negative x squared, positive 4x, minus 5. So I'm going to need a negative 1. And I get a negative x squared, a positive 4x, and a minus 5. And your remainder should be 0 because we just said earlier this is a factor. So we had two individual factors that when you multiply them together gives you your quadratic factor. When you divide out your quadratic factor, you get a second quadratic factor. And how do you find roots? How do you solve? You take that factor and you set it equal to 0, and then you're going to use your quadratic equation to solve. So I have 1 plus or minus, this looks like pot plus 9 over 2. And then when I do that, I actually have 1, sorry, equals 1 plus or minus this. So I could separate that. That's going to be 4 over 2 as well as negative 2 over 2. So I must have 2 rational roots that come out of question 6 as well. Oop. And when I look, I'm trying to see if did I add wrong? Oh, this is supposed to be a 4. My bad. This is a 4, not a 2. And so I actually get a 1 and a negative 1/2. So when it comes to how do you solve, if you know a rational root, you can find its conjugate pair, you can create factors, you can multiply them together to make their quadratic factor, then you divide by their quadratic factor to find another quadratic factor, then you can solve that quadratic factor by using the quadratic formula. Now, if they didn't give me an irrational root and I could use my calculator, what I would do for this question 6 is kind of answering the third question up here. How do I solve quartics in general when I can't factor? I cannot solve quartics in general when I cannot factor. I know, again, even if they gave me these two, I really didn't have to go through this whole process. I could use my calculator. So if I was going to use my calculator, I just want to make sure that I plugged my equation in correctly, and I noticed that I actually messed up on a negative sign. It's 2x to the 4th. I believe it's minus 9x cubed plus 13x minus x plus 5. Again, any problem that I can't factor, quartic, quintic, whatever, I would just plug it in my calculator. I'm going to hit graph, and I'm just going to look for those rational roots. And again, I notice it looks like a positive 1 to me, so I'm just going to guess and check. This one is a little bit harder for me to find. I might try to guess negative 1/2 and I got it right. So again, those are the same things that I found when I was looking at my other sheet. Answer the second question, writing equations when you know the roots. We kind of just mentioned how that would go, but I'm going to look at that same page. I'm going to look at page 381, and I'm going to look at problem number 5. It says find the cubic equation with integral coefficients, and it really is telling you the roots are 1/2, -1, and 3. So it's going to be a cubic because there's 3 of them. And then all you're doing is, again, you can write it a root this way. Just write their factors based on their roots. And again, that's just because they're roots, that would equal 0. And then you could distribute. Some people don't like the fraction, so you can also think of this as being, hey, any factor that gives me these values as their roots would work. So I could write this in factored form and distribute. Most people like to do this one because then they don't have to distribute a fraction. And you can decide which one do I want to distribute first. I might do this one first, and then I would distribute the next one. What do I get? 2x cubed minus 4x squared minus 6x minus x squared plus 2x plus 3. Again, combine your like terms, so 2x cubed minus 5x squared looks like minus 4x plus 3. So that would be an example of an integral coefficients. But again, I can pick any one that I want. I could have picked this to be my factor. My answer would look slightly different, and that's totally fine. So again, just a video to answer those 3 questions. I love that you're posting your questions. Please keep doing that, and I will try to keep answering your questions. Thanks.